PEC Module 4. Let's get right into this module. We're going to start off with fall protection. It's a national emphasis program this year. In the last couple years, and probably moving forward, that means that OSHA looks at fall protection seriously, and they're out to look for variations and violations of programs in fall protection, and it's our opportunity to do it right the first time. Some things that you should remember, our little logo popped up, which means there's some fill-ins in your workbook. OSHA mandates how high off the ground you have to be before you start using fall protection. In general industry, that is anything that's not new construction. If you're over 4 foot off the ground, you're required to wear fall protection of some kind. If you're in construction, you're allowed to go 6 feet. Some of the other segments of the industry, like workers working on iron, putting the steel structures together, they have a little different height limit. I think there's just 25 or 30 feet that they have to wear fall protection that's different. Workers must be protected from falling by personal fall arrest protection systems, the guardrails, and other safety nets or anything else that we can devise, barricading, those kind of things. Ladders and scaffolds or scissor lifts have their own fall protection requirements. So basically, if you're in a scissor lift that has its own basket with guardrails, then you're not going to have to wear a full body harness and protection system. Falls can break every part of your body and ultimately end up in you dying. Your company has to train any worker who's going to be exposed to fall hazards. You have to be trained before you are exposed, before you try to use a fall arrest system. This is a fall arrest system we see our partner here wearing. You'll notice that if he were to fall, he would be caught in the weight of his body would be split over his thighs, chest, and shoulders, not hanging from like his lower back like the old back belts used to be. A personal fall arrest system is designed again so that the system includes a full body harness, which is what we saw him wearing. That was the red harness. A connector that connects the lanyard to the point of contact where we're hanging from. That would be the anchor point. Connectors should include the lanyard, a deceleration device. Anything that's going to be attached to that must be strong enough to hold 5,000 pounds of pressure on the load whenever someone falls. And the reason that we have these kind of systems in place, because there's a lot of medical problems that can be derived from a fall and a quick stop. Along with that, we have some illnesses that can be derived from persons hanging in a fallen position in their harnesses. We have what's called orthostatic shock, in that all the blood pools in the legs. As blood pools, it can gel. It can also change the pH or the acid level in the blood and cause significant problems for the person even after they come out of the harness. A full body harness, as you can see here again, and we talked about with the other guy in the red, you can see he's got thighs and his waist are going to control the weight. His shoulders and chest and pelvis are also controlled so he doesn't have a whip action if he were to actually fall and need that fall arrest system. The anchor point, you see one here. There's a brake attached to this D-clip. Should be at the middle of the shoulders, above the shoulder blade arch, so that if he does fall, you're hanging in a position much like a marionette would. You're not doubled backwards. You're kind of hanging with your arms in front of you and your chin kind of towards your chest. And that way you have the ability to regain some stability and not be in an awkward position that could damage your spine in a fall. A deceleration device, I like these little guys. If you look at the picture, you can see it's a bunch of folded lines of fabric that have multiple seams sewn into them. So as you fall, each time that device takes the hit of your weight, it stretches out and it breaks those seams in each individual fold of that device. And you can see there it's only about 12 inches long, but it will spread out to 3 to 4 feet depending on how long that device has been selected for. And what it does is, as it tears with the weight of your fall, it slows you down. So there's not a fall into a dramatic stop. It's a fall that's transitioned in slowing motion down so that you don't have the snap at the end of a fall. Your lanyard connects the full body harness to the lifeline or the anchor point. It connects to your D-ring in the back of your harness. You should limit your fall to 6 feet. And again, if you're in general industry, we're going to talk about the 4-foot rule. Do not shorten your lanyard by tying knots in it, so that you can meet some criterion for the area that you're working. Say that your fall, you would come in contact with something that's a little bit closer than your lanyard is long, and they're trying to make it shorter. So I've seen a lot of guys actually do this, tie knots in there, but that actually weakens the fabric and can actually create a problem. When you fall and your weight hits that, it's just going to tighten that knot anyway. You give an opportunity for it to break, as well as go ahead and not really shorten it at all. Your anchor point is a securement point. Make sure that you attach to something. Again, 5,000 pounds. Many falls in industry happen with bad consequences because the gentleman who is wearing the harness chose something to connect to that couldn't control the weight of the fall. Before you wear a fall arrest system, it's your responsibility to inspect it before each time. If you see that that fall arrest system has got signs of wear that include little tears, that's faded in color, showing that there's UV damage, there's corrosion, chemical damage, or any other signs of wear, it is no good and must be removed from service. Get rid of it. A lot of times as a safety leader, I take these old harnesses and I actually take the scissors and I cut all the fabric out of them so that when I throw it in the dumpster, somebody doesn't come along behind it and say, oh, this one's still good, I'll use it in my leisure activities doing mountain climbing. If we take it out of service, it's for a reason. And one of those reasons is it's either not passed a visual inspection, or it actually somebody fell in it, and once someone's fallen in that personal fall arrest system, it's considered no good anymore. It did its job, and we bury that bad boy. All right, working elevated work, walking working surfaces, or any area above the ground where you could be required to do your work. It could be an overhead platform, runway, any elevated workstation on the oil field. We have the decks where the guys do all the pipe work and all the drilling production that happens right there on those elevated surfaces. Falls from these elevated surfaces account for 15% of all fatal occupational injuries. That's a big number. When you're considering one characteristic of the job of falls encompasses so many deaths, it's something that we should really take a great look at, and that's why OSHA has it as an emphasis program this year and the previous years to make sure that we understand falls and how to prevent them. 570 of those falls were to a lower level, and 114 of those falls were from more than 30 feet. It's crazy. Slips, trips, and falls are caused by a multitude of different things. A lot of them are carelessness. A lot of them, somebody chose to work on an area that housekeeping was bad. They didn't use the proper fall arrest system. They were climbing ladders in an area where the ladder could twist and fall. Their boots were wet and slick. The working surface was unstable, and they didn't take the time to look at the area to make a plan. So here's some do's and don'ts if you have to work elevated. Number one, don't run. Don't get in a hurry. That's just asking to come off the top of that elevated surface and meet the ground. Don't use chairs as ladders. Put electrical cords outside of the walkway so that they're not hanging in an area where you could trip. Keep your housekeeping up to date. If you use a tool, put it away. Make sure any floor openings are covered. Everybody knows what we're supposed to do. And again, in my opinion, carelessness and complacency are a lot of the reasons for falls, and they almost always can be removed from the job as a hazard if we just take the time to implement our engineering controls as well as use the proper PPE as designed and addressed by the company. Ladders. What's a ladder? Well, they're mainly designed to provide access to these elevated work surfaces. The ladder is a great tool if it's used correctly. There's some things that you have to be considered before we put the ladder into place. Number one, are we using the right ladder for the right job? Did we inspect the ladder? Does it have missing rungs? Are the feet in place? Is there bent or tarnished areas that provide for accidents to happen? One of the things that we have to look for in our ladder inspection is, can you read the label? If you can read the label, then you can know what weight limits are there, and you can know if this ladder is appropriate. The other thing is, we see a lot of guys get injured because they use the wrong ladder close to electrical components. You don't want to use any kind of metal or conduit ladder, conductive ladder, where you could have an arc flash grab your ladder. Now, there's two main types of ladders, portable and fixed. And then the other ladder that you're not seeing here would be a portable ladder as well. That's the single-sided ladder. This A-frame that you have here would be considered portable as well. Fixed or welded to structures. When you use a portable fixed ladders, you must face the ladder and use at least one hand to grasp the ladder when you climb up or down. You're carrying you up and down the ladder, so while you're carrying you, don't try to carry a bunch of other things. Don't try to use one hand to carry your tools. There are all kinds of ropes and devices that we can use to get your tools up to the elevated work surface. There's man baskets, there's tool baskets, there's all kinds of pulley systems that we can get stuff up there. The ladder is to move you and not your tools. When using a ladder, you should always make sure that your footing is appropriate and that you have a good grasp of the ladder. Put the ladder on a hard surface that's clean. Fully open the ladder legs and get authorization to be up on an area where you'd have to do the work. Here's a biggie. When you put a ladder against a building and you're going up to the top, say you're going to go on the roof, that ladder needs to go 3 foot past that upper landing. That allows you to go up and sidestep over instead of trying to go across the top of the ladder and trip yourself. When you do get this 3 foot over the ladder, it also ensures that you're using the proper size ladder if it meets the following ratio. And what the ratio means is we have a 4-to-1 ratio for the how straight up and down the ladder should be. So if we have a ladder that's leaning against a building, for every 4 foot in height of the ladder, the bottom should be removed from the wall, the base wall, 1 foot. So if you have a 12-foot ladder that's going up on a building, then the base of the ladder should be kicked out 3 feet away from the side of the building. And that's our 4-to-1 ratio. If we have a 16-foot ladder, the base of the ladder should be 4 foot away from the building, and so on. And that includes making sure that we have that 3 foot above the ladder, above the roof line, for excess ladder for the person to step over on. Whenever you can, it's always a good idea to tie off the ladder so that it doesn't slip and slide as you're moving up and down. Now there's a picture of what we talked about with the ratio, the 4-to-1 for rise and distance from the building, as well as the 3 foot extension past the top surface. Scaffolds. Scaffolds are not ladders. They're mainly used as work platforms. We see them a lot in big construction projects and where people need to work and use both of their hands, require a lot of the times on the job. Mainly construction style work, we see the scaffolds in play. They must be designed by a qualified person. You can't just go nail a bunch of boards together and make yourself a work platform. It has to be designed by a qualified person. It must be inspected by a competent person, and that person must be able to identify hazards and make suggestions for repairs and allow people on and off the ladder. Excuse me, the scaffold. A scaffold its components must be capable of supporting, this is interesting, most people don't pick up on this, its own weight plus 4 times of the maximum extended load, or intended load, forgive me, the maximum intended load. So if you have a 200-pound guy and he's going to have 1,000 pounds of bricks on his scaffold, that's 1,200 pounds. Now say the scaffold weighs 800 pounds. Now we're at 2,000 pounds for the man, the bricks, and the scaffold. So that scaffold needs to be able to hold 8,000 pounds to be in a proper compliance with OSHA's mandate. You never exceed the load capacity on a scaffold. Workers are not allowed to work on scaffold that are covered in anything that could reduce their ability to control their step. So if it's slippery because of ice, snow, oil, dirt, they can't go up on the ladder. They must not be allowed on the ladder. Every time you use a scaffold, it needs to be inspected by a competent person before each shift, and any occurrence that can affect the integrity of the ladder. So you got a big rain coming in, the ground got a little soggy, it's got to be inspected again. Even if you were just up there before lunch working on the scaffold and it rained during the lunch break for 10-15 minutes, it still needs to be re-inspected to ensure the integrity of the scaffold is still there. When you work on a scaffold, do not stand on extra things. Remember, the scaffold is your work platform. That's what you stand on. Don't put another ladder that's not part of the scaffold onto the scaffold planking to extend the height of your scaffold. If you need more height, you extend the scaffold. There are different types of fall protection, depends on the scaffold. There's not a uniform system for every scaffold. It's all based on how high you are and what kind of scaffolding system you're going to be used. Stairways and handrails should be kept in use of any stair that's got more than 3 steps. You have to have a stairway and handrail. When you're going up stairways, don't rush, clearly. Never store objects or materials on stairs where workers could trip or fall on them. Report damage immediately. Avoid carrying loads that block your line of sight. And be on the lookout for wet and slippery surfaces when it relates to any kind of stairway access or deceleration down to where they could fall. All right, let's go into guard guarding floor openings, wall openings, and holes. There are certain types of elevated work that can involve a floor opening. For example, your scaffolding may have an entry little hole that flips up the lid, and you come up through the ladder inside the next level. Then you need to close that little door so that people can get in and get out. If you have an opening in a floor, you need to use covers or guardrails to protect the workers so that they don't fall in there and unknowingly walk into a dangerous area. There was a video that was circulating about a bar, and this lady, she's in the bar and she's carrying down or carrying boxes of liquor up from the basement. This must have been in New York, it looked like, the area. She was carrying these boxes of liquor out of the basement, and she came up out of the basement. The door opens. You see her walk up the stairs carrying this box, and she goes over and she starts unloading the box, where there's a bartender that's actually working the bar, not knowing that she came up through the stairwell into this door, and she left it open. And the guy is working the bar. It takes a couple steps back, and he just disappears. And it's funny. The fall is funny until you find out that the guy actually landed on his back and broke his back and his pelvis, and was never able to work again. Careless, needless accident that happened. Didn't have to be a part of his life at all. Safety requirements depend on the type of opening in the floor. If you have a floor that's more than 4 feet, you may have to have some kind of fall restraint, but you definitely going to have some kind of system to keep people from accidentally falling into the floor opening. If it's 4 feet or more above the upper level, we can use covers like a door or a cap, a guardrail system, traveling restraint system so that you know that your weight is going to be controlled, and again, fall arrest systems as we've talked about before. Safety requirements depend on the type of opening or hole. Each worker must be protected from falling if it's greater than 4 feet, falling into a stairwell or through a hatch. All right, there's two types of falls, static and dynamic. A static fall means you're standing still and you fell under your own power, on your own weight. Dynamic means there was something added to your weight in the fall, maybe equipment or machinery or other moving parts. The consequences of these type of falls are the same. No matter how you fall, the consequence is going to be injury up to and including death. Your company has a requirement to protect you from falls. One of the things that we try to do is ensure in our training that you are aware of all these different protection methods and that you ensure that these are in place before you put yourself in an area of danger. Toe boards are on the planking of the floor of the actual scaffold. It's usually 4 foot and allows for a small gap between the toe board and the actual planking so that a tool could not kicked out and fall down to somebody below, or you won't slip off the side. Screens you see on the right side here, this looks like a light tower. It's got screens around it so people can't kick stuff off or fall. Debris netting would be at the bottom. Canopy structures, make sure that they catch things if they were going to fall off of the structure. And we require workers to clearly wear hard hats because falling objects can happen. Areas above the work area must be inspected and clear from objects. You see this guy, he's wearing a tool tie to make sure that if he drops that, number one, he catches it with his wrist tie that he has wearing there. And then a lot of guys fall when they try to catch their tool that they just dropped. This situation, these kind of devices prevent that from happening. We call those secondary securing devices because they make sure you keep your tools with you and you don't have to do this mad dance to try to catch them and ultimately lose your footing and fall yourself. There are a lot of different things we can use as secondary devices. It could be the wire you saw attached to the guy's wrist. It could be safety nets or other engineered devices that somebody who is qualified to look at a scaffold can determine is appropriate for our job. So let's go into excavations. Excavation is a hole that we put into the earth. An excavation is one of the most hazardous activities on the job because of cave-ins. The atmosphere can change. There could be underground utilities that we're going to dig into, water accumulation, and after soil is dug into or been disturbed, over time it can deteriorate in its ability to stay together, its cohesiveness, if you will. And after, depending on the heat of the day and the moisture in the air, these things can actually start crumbling where they were strong before. Underground utilities, if you're going to dig, most states require you to call and get permission. The 811 one-call service allows you to call ahead and let them come look at your area to determine whether or not you're safe to dig there. If you get into a digging situation, you cut a fiber optic line. That fiber optic line may control the 911 phone call system for your community, and you have disabled all 911 for the area. Secondarily, you may dig into something that's a live line, and you hit it with a piece of equipment and it fries whoever's working in that area. It's a bad day for everybody. Cave-ins. OSHA requires a cave-in prevention in excavations 5 foot deep or deeper unless the excavation is made in entirely stable rock. And you don't find that too much in the oil field. Entirely stable rock. I did pipeline work for a long time, and every now and then we would find stable rock, but for the most part, the excavation to dirt, we had to have some kind of device to prevent cave-ins. Excavation less than 5 feet deep must have a competent person to determine if protective systems are required. Methods. There's one of the methods we see there: shielding and shoring and bench. Shielding and shoring is right there. These guys are using these pieces of equipment to slide down into the walls, and those jacks hold pressure against the sides so that somebody could be in there. This is a pipeline activity where guys would go down in there and work on that pipe or weld or whatever they need to do, and that keeps the sides from caving in on the person. The shielding and shoring rely on mechanical structures. They should be approved and designed by a professional engineer and be sufficient for the job. Because they're so complex, the professional engineer must look at the job and determine what is sufficient to take care of the hazards involved in that kind of excavation. Sloping and benching. These are ways that we can widen the hole to secure the area from sliding in on anybody who would be inside right there. On the upper left, we have an example of sloping. I don't think that sloping is accurate. It should be quite a bit wider for that level of depth of a hole. But that's what sloping looks like. It actually makes the edges move out at an angle so that the dirt would fall and slide down versus just collapsing on top of somebody. Benching actually removes the type of fall hazard for the dirt engulfment away from where the guy is working. So were it to collapse, he would fall on the steps below and then down under the area where the guy is working. OSHA states that a competent person must inspect excavations, the nearby areas, protective systems every day, or if the condition changes. Rain and severely dry environments are enemies of excavations, and we really must pay attention when those are involved. Some additional precautions are bringing big pieces of equipment close to the edge of the excavation. That puts all this extra weight, makes the dirt have cracks, which we call fissures, and as the cracks begin to dry, they start to crumble. So we have to be very cautious on how close we allow people to drive their equipment to the sides of the right-of-way of the excavation, as well our spill areas. When we take dirt out of the hole, we must keep it back away from the hole and not so close that the actual weight of the dirt being removed will collapse the excavation itself. Workers must wear hard hats, safety glasses, side shields, and foot protection if that was identified in the hazard assessment by their organization. There may be other types of PPE that you have to wear, but that's all going to be determined through hazard assessment by the organization that you're working for. Barricades should be erected so pedestrians and equipment should be aware of the excavation and don't come too close. Again, I said that those heavy pieces of equipment, they come too close, they can deteriorate the integrity of the excavation quickly, and we have great hazards for engulfment when they do so. OSHA requires safe access and exit or egress for all excavations. So if you have an excavation, you got a hole in the ground that's greater than 4 feet deep. For every 25 feet of length, you have to have an exit, either carved out or a ladder system that can get them out of the excavation and get them out quickly. One of the test questions we had when we were doing excavations training on the pipeline was, you have a excavation that's 35 feet long, how many escape points do you need? Well, if you put one escape point in the middle, then you've covered the area, or if you did 25 foot and put one, you're still covered. So one is sufficient, two is better, and we try to do at least two when we have the first 25 feet is taken and then the second 25 foot is started. It's not required by OSHA, but it's always a good idea to have extra points of access and escape. Rescuers. So there's a lot of planning that goes into rescuing somebody in a excavation. Number one, we're dealing with a lot of weight. You consider that one big scoop of that front loader could be as much as 1,000 pounds. And so if you could imagine one scoop of a front loader caving in on a person, there's basically 1,000 pounds that just fell on top of them. So a plan must be ready, and emergency equipment must be there in the event that there is an excavation. The big key thing to remember is we don't use heavy equipment to try to dig somebody out, because we really don't know where they're at. So you're using your best effort to be careful, and the next thing you know, you're digging into a human body, and that severely weakens the chance of any survival in an excavation. All right, let's move into forklift safety. Very common tool that we see in all segments of the industry, both construction as well as general industry. Forklifts are also known as power industrial trucks. In fact, in most of your formal OSHA standards, you will see a powered industrial truck listed for where it says forklift. We use them to lift heavy stuff, heavy materials. They're essential in most of our operations. You can only use a forklift if you're trained, certified, and authorized to do so. There's a 3-part training requirement to using a forklift. You have to have some formal instruction, which requires kind of a classroom setup where you're talking about it. You need to be site-specific and forklift-specific for your hands-on training. So if you're using a Suzuki forklift on your site, you can't be trained on a Toyota forklift and certified on that Toyota and expect to be certified on the Suzuki. You have to be trained and tested on the forklifts you're going to use. And then finally, there needs to be a driving portion or a performance evaluation to ensure that you understood the training. Your certification is good for 3 years, at which point you need to be reviewed, need another performance evaluation, and make sure that you understand and do the job well. Because there could have been some changes to the layout of how you do things, or actually the equipment could have improved. Might still be a Toyota we're using, but maybe it's the newest model with some computerized operations that you need to be sure that you understand. Forklifts are classified by the power sources they use, be it a liquid fuel source, electricity, or whatever that they use to power them. They are used for the description as the first letter of whatever powers them. So you have an E forklift, that's an electrical forklift and it's powered by batteries. A D forklift will be powered by diesel, and so on. Forklifts, to use the forklift, you have to understand all the parts. The mast is the up and down device that the forks sit on. The nameplate tells you all about the forklift. We'll cover that in a minute. Any attachments and safety signage must be in good working order. You have to know how to use the controls. If there's a battery involved, is the battery secured and is it covered? The overall guards need to be in place. Tires should be inspected for gouges and for tread, and all the warnings devices must work. Again, warning devices must work, meaning you have to wear your seatbelt if you're going to use a forklift. So there's a nameplate for you. Commonly, forklift nameplates, they should meet the ANSI B56 standard. These forklifts labels must be approved by ANSI testing laboratories. So these forklifts tell you everything that forklift can do. It's got a capacity lifting on this one of 5,000 pounds. You can't exceed it, and it must be on that thing and visible. You got to be able to see it. You can't have those situations where it's there, but you can only read the first 3 letters of warning. And so you go up to the forklift and look at the nameplate and it says WAR. Well, that's not what you're looking for. You have to be able to identify what it is and what its capacity is before you use that piece of equipment. If you don't know, you can have an engineer look at your forklift. You can get a hold of the manufacturer, and they can assist you with updating your nameplates and so on. That nameplate, again, says some of the things it will tell you, what kind of fuel it is, how much it weighs, and what powers that bad boy to make sure that you understand what you can do with it. There's never a time when a forklift should be used in any manner other than what it's intended to do. It does not drive a car like a car. It's got a heavy backside. It will not corner fast. It will tip, and is not designed to do what these guys are doing here. I hope they were all removed from the organization just as soon as someone caught them doing that right there. 2 of the tire configurations that we use, and one of the ways you can tell whether a forklift should be used inside or outside, or in rough terrain or on cement. If it's got a solid tire, it's for level surfaces. It's for hard, smooth surfaces. If it's pneumatic, in other words, you put air in it, then it can be used outside where it won't lose its integrity if it goes over little hips and valleys in the road. There are some of your safety devices. I always look for backup alarms, fire extinguishers, seat belts and mirrors, and the horn right away. On my sites, those are the first things I look for, and then I work backwards into some of the other safety devices that we see here to ensure that it's all there. Look, if your stuff is not in proper working order, your safety devices are not there, then you have the right to stop the job and get them all fixed before you put yourself in a position where you could hurt somebody or yourself in this use of a forklift. Modifications are never authorized unless it's done by the manufacturer or you have a professional engineer come and do so. The companies manufacturer or an engineer can do any modification that they want as long as it's within industry specs and that the forklift has not lost any integrity for its safety functions. All right, let's step off into cranes and rigging. Cranes are extremely dangerous pieces of equipment. They're vital to what we use to do big lifts in all segments of industry. And you need to be aware of how dangerous they are if you're going to have an opportunity to work around them. And in the oil and gas industry, we basically use cranes every day. They're used for heavy lifting. They're unique applications, and they are specific to what you're going to be doing. There's 3 different kinds right there. The crawler is on the left. I'm sorry, in the middle there, kind of to the right. It actually moves itself under its own power. You've got pedestal cranes, which are mounted. Overhead and gantry cranes are all different forms of cranes that could be on your site that you need to be aware of. But here's what you should really be aware of. The crane operators that are going to be operating these pieces of equipment have to be trained. And not only do they have to be trained, they've got to be tested and they've got to be evaluated. And there's an ongoing process every so often that they have to be recertified in their skill level, just like you do with a forklift every 3 years kind of a thing. Ocean construction standard require that operators be trained and certified through a nationally recognized accrediting agency. In other words, you can't have Bob Wilson's crane certification program and get a card to go run a crane. It's got to be in a program that's been approved and accredited as a national organization. Even if a worker has completed the required training, they cannot operate the crane at your job until your company has qualified them as an authorized or a qualified operator of that piece of equipment. Some guys come in, they've been running cranes for years and years and years, and it's the temptation just to go ahead and throw them out there and say, all right, you're the qualified guy. But the reality is we still need to look at their training, and we still need to qualify them to run our cranes. The crane operator is ultimately responsible for every lift. Even if they determine that the lift is unsafe or safe, it still falls under them to make the decision, and somebody else cannot tell them to do the lift. I was offshore with a big company, and we have the offshore industrial manager, or the OIM, and he wanted our crane operator to pick some stuff up off the barge that brought supplies out, and the crane operator said, I'm not picking that up because the way that it was wrapped and the way that the rigger wanted to put it together could not safely take it off the vessel, and he refused. And the OIM wanted him removed from the company and fired, and the company's safety program backed him up and said he's ultimately responsible for every lift, and if he didn't feel it was safe, then he had the right to refuse that lift. The way that we talk to those crane operators is with hand signals, and what I would tell you is, though there are a few different versions of hand signals out there, as long as your rigger and your crane operator work out their hand signals before and they're standardized within your organization, then you're going to be okay. If the problem comes in when you have crane operators and riggers from different companies and they're both trying to use different versions of hand signs that haven't been worked out beforehand. All hand signs should be uniform within your company. Your all stop should be the same for every location, for every rigger, and for every crane operator, and even employees who need emergency stops, it should all be the same. Ocean's construction standard require that signal workers be trained and tested to demonstrate their competence in the standard crane hand signals, and that they understand how to make everything go up, down, back and forth, stop, and all stop and emergency stops, as well as go. With the exception of emergency situations, the only signal person that the crane operator should be looking at is the rigger, because that is his eyes and ears on the ground. That being said, the emergency stop signal can be done by anyone. It doesn't have to be the rigger. It can be quite literally the cook who saw something dangerous about to happen. He can throw the all stop sign and everybody shuts that thing down. You should only be one worker signaling the crane operator. As I said before, in most positions it is the rigger. This is the person that actually works with the operator. It should be line of sight between the two of these people. He ties the loads up, puts them on the hoist, and attaches them to the crane so that they can be lifted. There's some general rules for being a rigger. You never get under the load. You don't turn your back to the load. You have to be where you can see the operator face to face. Watch for pinch points. You know, when that guy goes to pull that load, if your hand's still in that loop, you're going to lose a finger. So it's your responsibility to make sure that you're not sticking your hands where they could be pinched off or caught in a load, because you could get drugged with the load and crushed. If the equipment, make sure that you're not in the swing path. If we got working on an area where the turn of the crane actually creates a swing where the thing may go forward and then swing back. If you're standing in that path, you're going to be destroyed when that piece of equipment comes back and strikes you. So being mindful of that and keeping others out of that swing path is extremely important. Know how to safely connect and disconnect if you're the rigger. That's why we have training programs for these guys to go to, as well as the training program for their hand signals, of course. And know the load limits of those things like slings and chains and ropes and wire devices that you're hooking to the crane, and that you don't overload them. We have to make sure that the inspections is done by the riggers and that we honor their opinion on whether the slings and ropes are safe. Make sure that they are in the habit of double checking their connections before making a lift, and that these lifts are done safely and without being in a hurry. So you're making a lift. They got the picture here. These guys are making a lift, and you got the guy in the orange vest with a rope in his hand. That's called a tag line, and what that tag line does is it helps control that load as it moves through into position to be put back down. Not saying that guy could actually pivot or pull that load into a direction quickly, but he can control the swing if it starts going in the wrong direction. If it's a big load, you may require 2 tag lines, and there's some other requirements that you must follow. You attach the tag line before the load is lifted. You make sure that the tag line is long enough to protect the riggers. In other words, we can get out of the way if something goes wrong. You always use 2 tag lines, again, with heavy or wide loads. You never tie the tag line around yourself. You make sure that there's no knots or frays in the tag line, so that you're not be dealing with something that can break unexpectedly. And the big thing is, if you're the guy working the tag line, you got to know how you're going to get away from the load if all blankety blank breaks loose, and how to get away in a safe fashion. Plan your escape routes. Know where to run. Know which direction is safe. Don't put yourself in a position where there is no escape route. And then finally, as I said before, never tie the tag line around your body. I've seen guys who loop their arm up in the tag line to help pull a load to themselves in an effort to control it, ultimately having their arm, the flesh ripped from the bone when they got a degloving accident, when the lift actually struck something and swung unexpectedly. What's a sling? A sling is a device that we pick up the load with that hooks right to the crane block hook. You never attach the sling right to the crane hook. There's some devices we use to do so. These are some of the different types of slings that we can use. We have, the chain. We've got the fabric, the wire rope, and so on. They have to be inspected by the rigger, whoever's using them, before each lift. If something looks frayed or damaged, we throw it away. We refuse to use it. Chop it up. Get it out of there. Don't just throw it in the trash can, because somebody else will pull it out and it'll be back in service before too long. Here's some of the hitches that we use to do a lift that the rigger will use. There's 4 basic hitches. What you see there is a vertical hitch. It comes straight down into some eyes, some hook eyes that they can lift the piece of equipment there with. A choker wraps around the source that is the lift and then comes back on itself. The basket hitch, it's similar to the first one with the vertical hitch. However, those are removable, and they're just an extension. It almost looks like what we call a whip check. In other words, you can hook up one side on the hook, and then you wrap underneath and hook up the other side. And then finally, a bridle hitch will use a combination of one or more of those different devices to hook it up. If you have the opportunity to work around a crane, be sure that you're wearing appropriate protective gear. Clearly, there's stuff moving above your head. You're going to need a hard hat. Foot protection is a must, because there's an opportunity to lose a load and land on your feet. Safety glasses, because you will be looking up watching loads. And hand protection, because you'll be hooking up wire ropes and different pieces of pipe and pieces of equipment, and the opportunity to hurt your hands is real. All right, let's move into motor vehicle safety. Motor vehicles, probably the most dangerous time of your day. Most people don't realize that the windshield time that you have is more likely to get you injured than actual working at the job site itself. Some safe driving practices, basically follow the law. The law is to wear your seatbelt. Remember the driving training you took in high school. Make sure your mirrors are ready. Make sure you're not distracted while you're driving. That's a big one in today's environment. A lot of people texting, a lot of people, we see this lady here doing her makeup. And always drive defensively. In other words, let the rude and aggressive guy drive away from you while you keep your distance. Those are always safe ways to go. Keep enough space for you between you and the other cars and other vehicles that you can stop, which means if the speed limit is 55, and there's a lot of traffic and the road conditions are bad, you may be doing something under 55. You may be driving less than the posted speed, just so that you can qualify the road conditions for what you're doing that day. Here's some lists of distractions. Some of them we think of, some of them we don't consider. Eating and drinking, big distraction. People don't really put as much into it as they should. Getting overly tired or fatigued. Oh, that's a big thing. They've determined now that being overly fatigued in driving is as dangerous as drinking and driving, if not more so. And as you grow up and become an adult, daydreaming about all the things you're dealing with in life become a big problem. And you catch yourself, you've driven 4 or 5 miles, and all of a sudden you snap to and realize, hey, how did I get this far down the road? It happens to us all. So it's something you've got to be consciously aware of and consciously be active in the driving process. And then finally, using that cell phone. I can't see that in the near future that we're even going to be allowed to have cell phones in our vehicles. It's just too dangerous. Too many people are getting hurt. And as younger drivers are coming up, we're watching teenagers get hurt in a greater number than we ever have before. Cell phone usage is just so dangerous. We've got to have compliance in our programs for these commercial vehicles as well as company vehicles that you're driving. Texting, there's no way you can do it safely as you're manipulating a vehicle down the roadway. You're just too distracted. Most states now have the hands-free driving. If you get caught with a cell phone even in your hand, you can be given a ticket. A lot of company policies now state if you get a ticket for distracted driving with a cell phone, or you get caught doing it with a cell phone, then you could lose your job. I've been on at least 5 different accident scenes as an investigator, where one of the first things that we did on a company was have them give us their cell phone records to show if the guy was texting before the accident happened. And almost all the time, somebody was involved with texting and then lost control of their vehicle when the unexpected happened on the roadway. Never use your cell phone when you're driving. All right, so let's get into commercial vehicles. If you have a commercial vehicle that you have to maneuver, you have to have a commercial driver's license that has to be rated for what you're going to be driving. There are 3 types of driver's license, classes A, B, and C, which are determined by the weight of the vehicle and the amount of passengers you're going to carry. If you're going to get your CDL, your commercial driver's license, there are some additional endorsements that you can get, your hazmat endorsement and those type of things, and there are more restrictions and more qualifications that are required for the professional driver. You're only allowed 1 CDL at a time, so you can't have one for Texas and one for New Mexico and another from Oklahoma. Wherever you're going to be working from, that's where your CDL should be initiated at. Alcohol and driving under the influence. What can be said? Look at this number. 30 people in the U.S. die in motor vehicle crashes that involve alcohol-impaired drivers. I have no patience for this. I have no tolerance for this. As a paramedic who's been on dozens of scenes where people are unnecessarily injured by the choice of somebody drinking, I just have no passion or compassion for these people. This is a choice you make, and in the industrial environment, in the company environment, we have 0 tolerance for driving under the influence, and you will lose your job. If you're drinking and driving in a company vehicle, you will lose your job. And in many of these organizations, if you get busted, they put you into a computer-based system that the next company you go to will see that you were fired for drinking and driving, and you will not have a job there either. So it's a choice that you make with long-reaching problems for yourself personally. Not only can you be arrested, but you could end up in an accident where you hurt yourself or, God forbid, somebody else. If you do consume alcohol, not that alcohol is not to be consumed. If you're an adult, you have the right to do so, but you are not to drive within 24 hours of consuming alcohol, and most definitely you are not allowed to come to our work site if you've consumed alcohol within the last 24 hours. Fatigue. It's just as dangerous as drinking and driving. You have to plan your driving schedule. If you get too tired, pull over. Your mental alertness is not there. You can go actually several seconds completely asleep with your eyes open before you realize, and you snap to it when your head finally jerks down. So if you're too tired to drive, pull over, make a phone call, and beat that fatigue. To control fatigue, you can reduce physical demands. I don't know if I agree with that. There's been many times when I've been really, really tired. We're getting out and doing some jumping jacks on the side of the road, walking around, taking some time to relax and refresh have helped me wake back up and deal with the fatigue. Avoid excessive overtime, get plenty of sleep, and have a good eating schedule. I like journey management. Journey management basically tells us how we can plan our drive so that we can safely do it in the right amount of hours and not be having issues with fatigue and other driving distractions that involved like lots of traffic or anything like that. So if you were told you had to drive between Houston and San Antonio, which is about a 3.5 hour drive, and you know that Houston's traffic between 6 a.m. and 8 a.m. is bumper to bumper, you might want to do your journey management to where you arrive at your Houston location at 4 a.m. so as to not be caught up in all that traffic and have a safer driving environment. You may want to arrive at 9 a.m. or 10 a.m. Again, journey management is how you determine how you can beat fatigue as well as beat those times when it's less safe to drive. Journey management makes workers accountable for planning their routes, and it also has responsibility to the company policy, and that we have driving accountability across the board from leadership on down. All right, seatbelts. I don't think this has to go very far other than seatbelts are the law. It's been proven that seatbelts have saved lives in the event of a car accident or an unexpected vehicle collision with an inanimate object. It is our policy. You will wear them. We don't just depend on a airbag if that's the safety mechanism in your vehicle. Those airbags are not used independently of seatbelts. They're used in conjunction with seatbelts. So if you have a seatbelt in your vehicle, you have to use it. If there's not a seatbelt or it's damaged, you need to get with Safety and Mechanical to make sure that that is repaired immediately. When you're driving a commercial vehicle, either a company truck or a large vehicle, it's your responsibility to inspect the vehicle to include turn signals, brakes, lights, tires, the air in the tires, the actual tread in the tires. All these things which could lead to an unexpected event or impair your ability to stop this vehicle need to be inspected and ensure that they're in proper working order. If they're not, don't take the vehicle. Talk to maintenance and safety to make sure that this vehicle is brought up to speed so that you're not in a situation where you couldn't control the vehicle if the emergency arises. Keep your gas levels up and your tire pressures where they're supposed to be. This helps with your usage of your gas. Make sure your power steering and all your belts and fluid levels, lights are all in working order and at the appropriate levels. Just like you expect that someone would do for your vehicles, if you gave them to drive, you need to do this for the company vehicles. You've been entrusted with a vehicle owned by the people who make your paycheck happen, and they expect you to take care of that vehicle to include making sure that it's safe to be down the road. All right, road conditions. When we do our journey management planning, we want to take into consideration what the road's going to look like. Are we going to be stuck in bad weather? Is this an area where wildlife is known to cross without notice? There's a lot of deer in the area because it's rut. There's heavy traffic or road work, or in the oil and gas industry, there's a lot of commercial vehicles moving up and down those roads, or road construction. If there's construction going on, those are considerations we need to take to make sure that we journey management the heck out of this situation so we can safely maneuver back and forth from our job tasks. These weather conditions may require you to drive less than the posted speed. You can actually be stopped and cited for driving the speed limit in an area where weather conditions are bad, and driving the speed limit could actually cause potential for injury to you or other drivers on the road. So your weather conditions can dictate your road speed in more ways than the signs on the side of the road do for you. Look for crossing signs for wildlife. In some areas that we know that animals are crossing, there's some signs, and the other places, you just got to know that you're in an area where there's a lot of animals that are going to be in that area, especially during breeding season. You should scan the edges of the road as you're traveling. You should always be driving at a speed that you can control and give yourself plenty of room to stop. Know where your emergency exit would be if you have to come off the roadway into some area to avoid some kind of animal that come on the road. The next best thing to do, and this was kind of the way I was taught growing up in a rural community, was if an animal runs out on the road and you have no ability to stop safely, you center the animal on the road and drive through. Other than rolling a vehicle down the road and risking your life and those people coming towards you and behind you, it may be better to just center the animal in your vehicle, slow down as much as you can, and take the impact versus whipping off the road and losing control of a 10,000-pound vehicle into the other oncoming traffic. Backing and parking. It is custom in the oil and gas industry that we back in for good parking. We found that most of the accidents that happen are when people are backing out of a location. So it's best practices that you back into all locations when you're parking. If you have access to these backup cameras, that is great. If not, get a ground guide out there who can back you in. When you back up, it's customary and best practices to hit the horn twice. That kind of lets everybody know in the area that you're doing something that they should look out for. If you don't see them, for them to get out of the way. This should be so common to you that you hit the horn twice when you're backing up. When you're pulling into Walmart and you back your truck into a spot, you should hit the horn twice, even if people look at you and give you a dirty look, because it's just muscle memory. I was in a location, one of the mall locations a few years ago during Christmas, and I had to stop on the way home from work to get some gifts at the last minute, and just muscle memory, I started backing up, and I hit the horn twice, and the next thing you know, I had this guy beating on my hood. I couldn't figure out what was going on, and I put it in park and kind of raised my hands like, what's going on? And next thing you know, I see this blue hair starting to come up over the end of my hood, and what had happened was, as I backed up and hit my horn twice, just out of muscle memory, his grandmother was passing in front of my truck, and I literally knocked her down with the horn. I felt bad. I apologized to him. He was an oil field worker too. He understood. But that should be how it's ingrained into you, that if you're going to back up, you let everybody know. Honk, honk, and then you make the move. All right, load securement. If your job is securing loads or taking loads off of a trailer or some device that's been hauling them, you must make sure that you know how to do it correctly. And let's just read this right here. It says, cargo securement prevents materials from moving or falling by using the vehicle structure, securing devices, blocking and bracing, and a combination of the three. I can tell you that if you got a pickup truck and you're tying a load into your pickup truck, using the fender well and straps that have ratchets on them is a bad idea. Those are not made to do that. You will flex the fender wall out, damage the vehicle, and you will not have the load adequately secured. If loading and securing is part of your job, it's your responsibility to be familiar with certain laws that may be in place. With some of these DOT laws, they may have a certain width of how the securement device should be, the strap. They may have a certain amount of straps it should be, one every 4 feet, one every 10 feet, and so on. So if that's your job, you must make sure that you follow the appropriate laws. The other thing is you must make sure that you're putting straps on those loads that have been inspected. Don't use frayed or weather torn or faded straps. They have to be in good condition and ready for the job. When you're unloading or loading, make sure that unnecessary personnel are not in the area so that they don't get struck as we're putting the load on the vehicle or taking it off. Do a hazard assessment. In other words, do walk around. You may need to drop cones. You may need to put up a sign that there's a process where moving vehicles will be moving heavy equipment or heavy loads with limited view. You may need a guard to stand with you out there to make sure that keep people away and traffic away, and that you finally secure those loads appropriately for the lift. If you're going to chalk the tires, make sure they're appropriate. Make sure you use the appropriate chalk. You can see these tires have the grooved chalks, so those are the best we can put around the tire. They did front and back, and they chalked it in a way that if it were to roll, it would catch the other side, and it's in a great position. This person who did it very well. All right, that's the end of Module 4. We're going to take a short break and come back, and then we'll be right back into the training.